Hello everybody, welcome back. This lesson we're going to be doing compound inequalities. So in the last lesson we talked about inequalities in general. This one we're going to talk about compound ones, which are a bit different and kind of more difficult. So first let's go into our definitions. A compound inequality is an inequality composed of several shorter statements, each connected by an and or an or. This sounds super weird, right? We have ands and ors. This is math, not English. What's going on? Don't worry. So each and each or has a different name. The and ones are called a conjunction. The definition is just an inclusive compound statement joined by the word and. So let's break down some examples first so we can try and understand exactly what this means. There's another definition that we should know, an intersection. An intersection means all of the common elements from the different sets, and it's represented by a symbol which looks like an upside down U. That looks pretty weird. And how are we going to try and remember this? Later on in the video, there's going to be a way to remember if it's a right side up U or an upside down U. So let's look at this example. -3 is less than x, and x is less than or equal to 1. You can look at this side as x is greater than -3, just like we were looking in the last video with x always being on the left. But eventually we'll get used to this new notation where x is on either side. So the solution, rather the intersection, is going to be this phrase right here. -3 is less than x, which is less than or equal to 1. The most common way we'll solve this is by graphing. So first, let's graph the left green side. First, we're going to have an open circle because we're excluding the value of 3, and we're pointing it to the right since the values of x are going to be greater than 3. Next, we're going to graph the right side, the red side. So we're going to have a closed circle since we're including the value of 1 and we're moving left because x is less than or equal to 1. The way that we're going to figure out what the intersection is by looking at the common elements in this. The common elements are going to be where both of these separate graphs have values. So that's where I just highlighted. But here's something important to note. We're going to be including the value of 1 on the right side because 1 is included in both of these previous graphs. However, we're going to be excluding the value of 3 in our solution since 3 is excluded in the first graph. Now, when we write out the actual solution, we're going to be using our new notation with that upside down U looking thing. So here we have the values of x where -3 is less than x, intersection, the values of x where x is less than or equal to 1. Fantastic. Let's go back to one more thing before we move on to disjunctions, an empty set. An empty set means that there is no values in common in the solution set. For example, x is greater than 3 and x is less than or equal to 2. This would be considered an empty set of a conjunction. For example, x greater than 3 means that all of these solutions would have to be positive, but x less than or equal to 2 means that all of these solutions would have to be negative. We use this symbol right here, which we call not, spelled N-A-U-G-H-T, to represent an empty set. Not is also used in other mathematical things, just basically to mean that it's the zeroth something or another in a list, or means that it's empty. It's basically drawn by drawing in 0 or with a diagonal line through it. You're not really going to come across it super much, but just to recognize if you do see it. Let's try these two examples before we move on to disjunctions. So we're going to skip the previous two, let's graph the other two separate steps because I feel like we're ready to move past that. First, this side. -2 is less than or equal to x, which we can also write as in our previous video, x is greater than or equal to -2. Close circle at 2, and we're going to move right because x is greater than it. Then x is less than 1. Open circle at 1, moving left. So the solution is going to be between -2 and +1, excluding the value of 1. Let's write that with our new notation. X where x is greater than or equal to -2, intersection, upside down U, x where x is less than 1. Fantastic. Next question. We're going to have to solve for this like we learned in our last lesson. So let's subtract 4 from not each side, but all sides. It's ugly. Let me erase that. So now we have negative 6 is less than or equal to 3x, which is less than or equal to 3. Divide by 3 on all 3 sides. Now we have negative 2 is less than or equal to x, which is less than or equal to 1. Great, so we have a closed circle at negative 2 and a closed circle at 1. From negative 2, we're going to, basically x is greater than or equal to negative 2, so we're going to move right. Then from negative 1, we're going to move left. So our solution set, our intersection, would be x, where x is greater than or equal to negative 2, intersection x. Whoops, upside down U. Look at that, Jocelyn. X, where x is less than or equal to 1, including both of these values. Next, disjunction. Disjunction is our OR example. Disjunction is an exclusive compound statement joined by the word OR. So basically, we can start this by graphing the two separate ones. Just like we had an intersection with our conjunctions, we have union with our disjunction. So here's how we're going to remember if it's our upside down U or right side up U. Union starts with U. Therefore, it's our right side up U. Pretty simple. It'll help you remember it. So the union is a set obtained by joining 2 or more sets. Let's look at this new example. Negative 2 is greater than x, also can be written as x is less than negative 2, or x is greater than or equal to 3. So open circle negative 2 and going to the left, closed circle positive 3 and going to the right. So basically our solution set is either of these sides, written with the union side. Here's something a little tricky about the actual textbook definition of a disjunction. It says an exclusive compound statement, which is a bit weird considering our actual solution statement will include both sides. Basically, the word of exclusive here means that our individual single point solution that we may have in a generic situation can only be on one side, either this side or that side. It can't be simultaneously in both. It can't fit either equation at the same time like it did with a conjunction. Don't overthink the actual textbook definition too much. Let's try and graph some examples. First, we have our negative 3 is greater than or equal to x, which also means x is less than or equal to negative 3. Close circle at negative 3, moving left. Then x is greater than or equal to 1. So close circle at 1, moving right. Written in our new notation, we have x, where x is less than or equal to negative 3. This is a union, so up right U. Now x, where x is greater than or equal to 1. Fantastic. Moving on. We're going to have to do a little math here, so let's subtract 5 from both sides. Negative x is greater than negative 2. Oh, look at this. We have a secret 1 situation, so let's divide each side by negative 1. Remember, when we're dividing by a negative, we're going to have to flip the sign. We learned this in the last video. So now we have positive x is less than 2. Fantastic. Other side. Subtract 1 from each side. 2x is greater than or equal to 8. Divide by 2. Divide by 2. X is greater than or equal to 4. So over here at 2, we have a closed circle and we're moving it left since x is less than. Then over here we have I'm sorry, I said it wrong. On the 2 we have an open circle. Then on the 4 we have a closed circle. We're moving right because x is greater than. How are we going to write this? X, where x is less than 2, union x, where x is greater than or equal to 4. Fantastic. That's it for now, guys. Stay tuned for our next video, which should be about, I believe, absolute value. Exciting. See you then.